In this video, we're going to define absolute extrema and understand the extreme value theorem. It says, consider the function f of x equals x squared plus 4x minus 1 to the 3 halves minus 9 over the interval 3 to 8. Does the extreme value theorem guarantee the existence of an absolute maximum and minimum for f of x on this interval? So the extreme value theorem, I'm just going to say EVT, has two parts to it really. And it says that we need to have the function bounded, which we do, bounded by 3 and 8. And then it also says that it needs to be continuous. If those two things are true, then we've got, then we can guarantee that there is an absolute maximum and minimum on that interval. So right now we're bounded. We just need to see, is it continuous? So to figure that out, we really just need to see if we can plug in values between 3 and 8 into this function and still get real numbers. So we've got 3 halves here. So this would be, let's write that a little bit better. We got 4x minus 1 to the 3 halves. That's really our only issue in this function. We can plug 3 and 8, any value from 3 to 8 into x squared. The question is, can we do that for 4x minus 1? So we're going to say that that is the root of 4x minus 1. And then I'll just put parentheses cubed. Now, I really only need to test this radical, okay? Because that's really going to be my big issue is what values can I plug in to this radical and still get a positive number out, or a positive number inside the square root. So I'm going to say that I cannot have, so 4x minus 1 cannot equal 0. Or actually, we're going to say not equal, has to be greater than or equal to 0. So to figure this out, I'm going to go ahead and I want it to be greater than or equal to 0 because I can't have it be negative. If it's negative, then we have values that are not real. So we're going to add 1, so that'd be 4x greater than or equal to 1. Divide by 4, x is greater than or equal to 1/4. So it says my x values have to be greater than or equal to 1/4. Well, our interval 3 to 8, all those values are greater than or equal to 1/4. So that tells us that we're continuous on the domain here. So yes, the extreme value theorem guarantees that there's an absolute maximum and minimum.